Hello friends, in today's video we'll be discussing about gyroscope. This gyroscope is a very mind-boggling, non-intuitive device. So I thought that let us have some fun with it. This is a gyroscope. This comprises a disc which is a very rapidly spinning disc. Okay, now if you observe the situation from here, now this is the disc. And if you observe it from this side, you will see the entire face of the disc. So if you observe it from here, or if you observe it from this side, from the side, then you will see the entire face of the disc, like this. It's a circular disc, and this is the front view. Now this disc is rotating like this. So if you observe it from this side, the disc is rotating in clockwise direction. This cross means it represents that this point of the disc is moving into the plane of the board, and this dot represents that this point of the disc is sprouting out of the plane of the blackboard, of the whiteboard. So now just picturize the scenario. The disc is rotating like this and it is mounted. This is the axis of the disc, and this end of the axis is attached to a cable, and the other end of the cable is attached to the ceiling of the roof. Now this is the situation. Now this disc is rotating in this direction. Now because it is rotating very rapidly, so it will be having some angular momentum. The direction of the angular momentum can be achieved by curling, this is my right hand, by curling the right hand fingers in the direction of rotation of the disc. The extension of my thumb will give me the angular momentum, the direction of the angular momentum. So this is the direction of the angular momentum. L stands for the angular momentum of the disc. So we are assuming that it is rapidly spinning and the angular momentum is in this direction. Now this is the point of suspension. So assume that if this disc is not spinning, suppose I stop it from spinning. So now it is not spinning, and if I am holding this axis at this point, then definitely the disc is stationary. Now if I let it go, release it from here, definitely the ring of this disc will flip down. This disc will definitely flip down. So that is what is expected, and it's very intuitive also. But now let us see what happens if we rapidly rotate it in this direction and we are holding it at one end, and if we let it go, then what will happen? Then if you do this, now if you release it, and imagine that this disc is rapidly spinning, and now you release this end, then the disc will not flip down. Now this is quite contrary to my expectation or expectation of other people, because at the face of it, it appears that it is defying gravity, because it will not, this spinning disc will not fall down. Instead of not falling down, it will not fall down, but it will start rotating like this. Now this motion, still it will start drifting in this direction. It will start moving along a circle in this direction like this. Complete circle it will make. Now this motion is known as precession. This motion is known as precession. This is precession. So instead of falling down, it will start moving in this direction like this along a circle, and this motion is precession. Now I'll explain here what is the physics behind it, what is physics behind this precessional motion. Okay, now if you consider weight, this is mg, suppose this is the force, this is F, suppose this is F vector. Now this mg, or the weight, is applying some torque about this point. This is the point of suspension. The torque about this point, let us say that this point is O. The torque about the point O is defined as R cross F. Now how do you find the direction of R cross F? Now this is, because we want to find the torque about this point, and this is the force, and we want to know what this force is applying, we want to know what is the force applied by this force about this point of suspension. Then this is R vector, here it is, this is R vector, and this is S vector. F is the weight. So now R vector goes like this and F vector goes like this. So this is my right hand. Now if I rotate my tip of the fingers from R to F, then the extension of my thumb, because I want to know what is the direction of R cross F, and if I rotate the tip of the fingers from R to F with my right hand, then the extension of the thumb will give me the torque about the point O. So this dot means the torque vector is sprouting out, or it is emerging out from the plane of the board. This is the direction of torque. Now we know that torque about the point O is dl by dt. This is the torque. Torque is dl by dt. This is in vector form. This is the vector expression for torque. Now, actually this is rotational analog of Newton's second law. So from here it is evident that the direction of the torque is same as the direction of dl vector. dl means change in the angular momentum, a differential change in the angular momentum, and dt is a very small span of time during which the angular momentum has changed. So now initially at this position, this is the direction of L vector, and this is L vector, and this is L vector, and this is the direction of torque. So this will be the direction of dl vector. So initially L vector is like this, and dl vector is in this direction. So that this means that the change in the angular momentum is in this direction. So initially the angular momentum is like this, and if I release it from here, then the angular momentum will change, but the change is in this direction. So definitely this vector will rotate in this direction like this. So it will rotate like this. So that this disc will start precessional motion. So it will move like this. So instead of falling down, it will rotate in a horizontal plane like this and make a complete circle like this. It will not fall down. So it's quite, I would say, weird or non-intuitive. So this is how this gyroscope works. Now, on the same principle, you see this is, if you see this figure, this represents a rapidly spinning top. So this top, this is the top, and it is spinning very rapidly like this. This cross is representing that this point is moving into the plane, and the dot represents this, that this is emerging out of the plane of the whiteboard, this board. So this top is spinning like this. If I curl my right hand fingers in this direction, this is the direction, then the extension of the thumb is giving me the direction of the angular momentum or angular velocity, omega. Now this mg is applying some torque about this point O. This point O is fixed on the ground. So mg is applying some torque about this point. So in context to, with reference to this point, this is r vector. It goes like this, r vector, here it is, and this is mg vector. This r, this is mg. Curl your right hand fingers from r to mg, and this is the direction of the torque about the point O. Let's talk about point O. Again, it is emerging out, and the direction, again, the direction of the torque is the same as the direction of dl vector. dl vector means the change in the angular momentum. Now, initially this is L vector, and this is the direction. This is the direction of dl vector. So this L vector will rotate like this. So it will sweep out a cone like this. So instead of falling down, it will sweep out a cone and not fall down. But the moment you stop this top from spinning, it will definitely flip down due to the gravity torque. I hope you liked the lecture, and I hope you appreciated the physics behind gyroscope. Thank you very much, friends.